Thank you for joining me. I am Mr. Ish. Binomials over here. This is a frequent source of irritation for students. When you are given a binomial but you have to present only a specific term from that expansion, how can you do it? I'm going to give you a shortcut over here on how you can do this type of question and not get it wrong. The first thing you're going to do is look at your n value. What's your n value over here? It's the exponent of your binomial. N is equal to 7. Simple as that. What you're going to do is create a series of items. And look what I'm doing. I'm creating what would have been normally your coefficients, your combinatorial coefficients, which would have applied to your expanded binomial. Anyhow, I'm starting here with a 7, 0. Then what am I going to put? I'm going to put here a 7, 1, and then 7, 2, and then 7, 3, and then 7, 4. Why am I doing this? Because it will be apparent to you momentarily. And then we're ending with 7, 7. The minute those two numbers, the upper and the lower, are equal to each other, you're done. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. The number of terms is always n plus 1. You have 7 here, so 7 plus 1 here, it must be 8. It always expands to n plus 1 number terms. Now look, I have to find the third and I have to find the fifth terms. The reason why you're doing this is because you're going to mark off clearly what you need. So what do you need here? You need the third and the fifth term. I'm going to count literally. Here's my start. Right here. I'm going to count and find the third term. 1, 2, 3. Here's my third term. And now I'm going to do the fifth term. 1, 2, 3, 4, 5. Here's my fifth term. Now what do I have? 7, 2 and 7, 4. And that's exactly what I'm going to use. My third term. Let's classify the third term with the exact specifics. We have 7 and 2. And then what are we going to have? Right here. 4x and y. How do I know what I put over here? It's simple. You're going to do right over here n minus r. Here you're going to put r. Now what's n minus r and what's r and all of that? This number right here is always your n. This number here is always your r. I have 7 minus 2, which is going to come over here, and I have the 2 which will come over here. So exactly what I'm seeing, I'm going to substitute it. 7 minus 2, I'm getting a 5, and my r value 2. Compute this. How do I know what this equals right over here? It's nothing more than a combination, a combinatorial coefficient, which is NCR. And the formula for that is n factorial over r factorial times n minus r factorial. You can do this, it's not hard. When you do this, you're going to be basically doing 7 factorial over 2 factorial, 5 factorial. We can do that. But why don't we just do that here on our calculator? Because we know the formula is that 7 factorial is 5040 divided by 2 factorial, which is just 2, divided by 5 factorial, which is 120. That's 21. That's what I have, 21. 4 to the power of 5. I'm getting here times 1024 x to the power of 5 y square. When I combine these together, what do I have? I'm doing 21 times 1024. I have 21,504 x to the power of 5 and y square, and that should be it, and it should be right. But this right here is my third term. Let's do our fifth term. 7, 4. What am I going to put right over here? Obviously inside you're putting 4x, but what's the exponent? It's n minus r. 7 minus 4, it's 3. And for the y, the exponent here is always r. What you see right here will just come exactly right over there. Combinatorial coefficient, it'll be exactly that. 7 factorial divided by 4 factorial, 3 factorial, because it's n minus r factorial in the parentheses. We'll do 5040 divided by 4 factorial, 24, divided by 3 factorial, which is 6. 35. That's the coefficient here. Your combinatorial coefficient is 35. You'll have 4 exponent 3, which is a 64x cubed, and then obviously a y to the power of 4. What's 64 times 35? Well, that needs to be determined. I'm getting 2240 x cubed y to the power of 4. Lastly, why do we do the number on the top? It stays the same and the number here creeps its way up, because this right here is your anchor value, your n value. Your r value must work its way up, because as you see in terms of the variable exponents, as one is decreasing, the other one is increasing side by side until one is exhausted and the other one comes to the complete value. If you expanded this entire binomial, your first variable in terms of x would work from 7, go all the way to 0. Your y variable would start from 0 and go all the way up to 7. But this is exactly how you want to do these type of questions. Set it out this way and then literally count your terms. 1, 2, 3, this is my third. 1, 2, 3, 4, 5, this is my fifth term, and run it through using this. Have a good night. Bye.